Welcome to Oklo's very first AMA. I'm Bonita Chester, Oklo's Head of Communications and Media. Thank you for tuning in, and a big thank you to everyone who submitted questions. We appreciate your engagement. We're excited to provide as much insight as possible into our operations, development, and future plans. Joining me today are Jacob DeWitte, our co-founder and CEO, Caroline Cochran, our co-founder and COO, and Craig Bealmear, our CFO. They're ready to dive into your submitted questions and share their perspectives. So let's get started. Jake, let's go ahead with your first question.
Thanks, Bonita. And thank you guys for sending in some questions. Excited to talk through some of these. So question in here is, in your opinion, why should investors bet on Oklo versus other companies? And what is your plan to deliver value to shareholders? It's a good question, one we often get. And I think it focuses on a couple of the key aspects of differentiation for us. One is around the business model. The other is kind of around size, and technology is also just progress to date and capital efficiency. So for the first one in business model, this is a big thing for us about kind of why we started the company in the first place. Looking at all the wonderful attributes that nuclear has to offer, clean, reliable, affordable power, a lot of people want to buy it, but the conventional model made it really difficult for people to buy that. So typically you're talking about companies designing reactors to like 80% completion and then going off and trying to charge a fee to potential customers to then have that customer take over, complete the design process, site it, permit it, own it, operate the plant. Just a lot of friction. And so we saw a lot of opportunity to make it easier. And that was what we focused on. So we take a design, own, operate approach, making it easy for our customers to just buy what they really want, which is the power. And then we get the benefits of having the experience of going through and verticalizing that, but also getting the recurring revenues that come from that. But most important is giving what customers that we've seen really want. And we see that manifest in how our backlog is developed. Additionally, we see a lot of benefit in how we approach this from a technology perspective. We're picking up on the next most mature reactor technology after water-cooled systems and our use of sodium-cooled reactors. Sodium is a wonderful coolant. It's able to operate at high temperatures without being pressurized. It's compatible with common alloys and form factors that are similar, if not identical, to what you see in many other industries. So you can tap into those existing supply and value chains and get a lot of the benefits from those already existing, rather than being bottlenecked or constrained across a number of different parts you need in your plant by non-recurring bespoke kind of components that you would otherwise have to have. So those are important aspects for how you can quickly benefit economically as well as scale. And then you also benefit from a very mature technology that has a long history of operation behind it. And then the other part is around size for us. We wanted to start at a size range that matches with how we see customers going and providing kind of a flexible but meaningful solution on the energy side for them. We see that manifest because a lot of our energy user customers are often looking at facilities or projects that are going to grow in their power needs in a phased approach over time. And at our sizes of 15 and 50 megawatts, we can match that growth rather than building a plant that's way oversized and having to have them grow into it. And then the uncertainty at a project level that comes from that. And we've seen challenges of that in the past with other projects. Additionally, it helps it helps actually enable the opportunity to give a reliable power solution to our customers. Because this isn't just like a virtual feel-good kind of PPA. This is a meaningful, like existential kind of operational power that we're providing to these facilities. So we need to make sure it has the right uptime for them. And so in some cases, we'll be overbuilding by the capacity by building more plants than you would need to deliver their capacity. But that way we have that extra capacity on hand to deliver to their needs. And that economically works out because we're not having to build a huge amount of extra capacity to do that, because our size allows us to do that in a more granular fashion. And then in terms of progress, I mean, this is one of the big things that we've tried to focus on: building partnerships to leverage existing technology experience sets, government capabilities and facilities as much as we can. So that kind of positions us in a unique way where we have a site use permit from the Department of Energy to build our first plant in Idaho. We have fuel that was awarded to us through a competitive process from Idaho National Laboratory. And we have long-term, I should say, of regulatory traction going back to 2016 when we started engaging formally in pre-application with the regulator here. And then additionally, on top of that, now, starting smaller, you also reduce kind of the total amount of capital needed to get to a first plant built. And now we've gone through the process of raising quite a bit of capital to be able to actually be on the path to deploy that. So that puts us in a good spot to deliver power. Aiming for the 2027 timeline to start that up and start delivering power. Um, Pretty significant sort of timing advantage given all those features, and we're kind of the only company that has that aggregated amount of progress across those big fronts. Additionally, there's this significant backlog that we're going to talk a little bit more about. I think, given some of the questions that show kind of what some of the exciting growth comes, that's a reflection of the progress we have in those areas. But just to go to the last piece, which I think is value and capital efficiency, we've demonstrated, generally speaking, a strong level of capital efficiency in how we've been able to operate and execute the business with a strong focus on doing that going forward by, again, maximizing how we approach leveraging prior experience, avoiding major R&D needs on the technology side, to then focus on being able to actually get a plant built more capital efficiently as well as more time efficiently, so to speak. So those things I think position us well as well. So with that, I'll go ahead and pass the next question on to Caroline.
Yeah, the next question I have is, with regard to the recycling business, how are we looking to communicate with the general public about the benefits? I love this question because, it's so rare that there's something that makes such a huge impact on our business, but also has a huge impact on public perception and actual have societal benefit. When we talk about our recycling business, we usually break it into three really key points. And those three key points are related to how it can reduce our fuel costs, how we can capture storage fees for existing nuclear waste, and how we can use the co-products of recycling, that is the isotopes, have a whole other business line that is also well in sync with our main core business. But each of these three things actually is really impactful for the general public and really important to them too. So I'll kind of walk through that here. With regard to reducing fuel costs, obviously that's important to our bottom line, but what that means is we can ultimately reduce power costs. And that is hugely impactful on anyone who is a customer of that, right? To be able to access power that is clean, but also affordable, especially as power prices across the United States are high and set to just keep going higher, essentially. That is an enabler for everyone across society to be able to have access to clean and especially affordable power to power their everyday lives. With regards to storage fees, it's a little more nuanced, but basically right now, utilities and therefore ultimately the ultimate consumer are paying a little bit to store waste. One of the good things about this, of course, related to nuclear power is we know where basically every atom of waste is, whereas many other power sources are not so clean or diligent. But it does mean that there's a little bit of incremental cost to everyone down the line. And this is yet another place where if we're, as Oklo, taking that fuel that's currently being stored and just not used, and we can use it as fuel for our power plants and reducing the cost by up to 80% for our fuel costs, and fuel costs is one of our single biggest costs of power. We're providing cheaper power, but we're also getting a potential revenue stream from those companies that now don't have to pay to store that waste, and it's useless to them. And we can take it at a beneficial kind of win-win scenario from them. This addresses a couple of things that the general public worries about. One is, what are we doing with nuclear waste? And the other one is, just once again, having another avenue to reduce the total cost of power for people who need it. And the last one is around isotopes. This might seem like a bit of a departure from our core business, but because the recycling is so key to how we see the future of providing power and reducing our fuel costs and having domestic fuel supply chain, we're also making these co-products that are immensely valuable to society, which are isotopes. These isotopes can be useful for a range of industrial uses, but probably the most obvious and impactful is the use of isotopes in different medical applications. So Right now, globally, there's a huge shortage of isotopes for different medical uses. And these literally are life-saving imaging and other procedures that need these isotopes. And currently, there's not a sufficient global supply. So you can have a measurable impact in individuals' lives that are currently ill or needing this life-saving treatment, and hopefully also reducing the cost by increasing the supply of these key isotopes. So while we're able to capture the benefit of creating these co-products, I think the general public is excited about hearing about that story, about learning, about the impact that these materials can also have more broadly. So it's a really exciting topic for us. And so thank you for the question.
So my name is Craig Bealmear. I'm the CFO for Oklo, and I think the next question is to me. Does Oklo have a recurring revenue plan? And if so, how exactly does it work once the plants are operational, and for how long? So the way I'm going to answer this question is actually quite complementary to one of the things Jake has already talked about, which is our build, own, and operate model. And so our plan is once a powerhouse is up and running, we're actually going to sell power through something called a power purchase agreement, or PPA. And we intend for these power purchase agreements to be anywhere from 20 to 40 years in duration. So Jake was talking earlier about how we're going to provide reliable power to our customers. One of the things that's great about selling power through a 20-year PPA is we're going to have a reliable revenue stream coming back in once those plants are operational. And selling power through a power purchase agreement is not something that Oklo is inventing. It's actually something that's already in use today in many of the energy sectors, such as wind and solar. So it's something our customers are already used to. And the final thing we like about being able to sell power through power purchase agreements is it's going to give us certainty in a revenue stream. That certainty in a revenue stream actually will allow us to go out to the capital markets and potentially borrow against that revenue stream through something called project financing. And then what we can do there is bring forward those cash flows from project financing and, in a sense, use the cash that comes in from project financing to finance subsequent power plants. So it's a great model. It's one that's already in use, and it's really complementary to what we're trying to do in terms of being a builder, owner, and operator of powerhouses. I think the next question goes off to Jake.
Thanks, Craig. Yeah, the next question that we get in here, and we get this often, is when and where is your first plant expected to come online? So yeah, we've announced a number of plants, which we're very excited about. But generally speaking, we look at the first mover being our plants in Idaho. That's at the Idaho National Laboratory near Idaho Falls, but it's a fully commercial plant. We expect that plant to come online in 2027. We've got a site use permit from the Department of Energy. We have fuel allocated to us, and as part of that process, a lot of regulatory traction to date on that. So that's where we expect the first plant to come online. Then we see other plants behind that we've announced. We've announced 2 plants in Ohio. We've had the progress we've made with the Alaska Air Force Base. Additionally, we have the partnership with Diamondback Energy in the Permian Basin in Texas, as well as Wyoming Hyperscale in Wyoming. So that's kind of a preview of some of the backlog. We'll talk a little bit more about that. But Idaho is where we expect our first plant to come online. All right, so related to that is a question on regulatory. So Caroline, I'm gonna hand that one off to you.
Yeah, so the next question being, basically, what are your NRC timelines and how do we develop those? Why do we have some confidence around them, or where do we get that information to build those? And so I'll say, it is tough. There are a lot of different timelines and expectations and ways to build this. But I'll say at the very top level, one thing that's been really important to, I think, the nuclear industry is a bill called NEMA. It's acronymized NEIMA. And that was passed some years ago, but in that, Congress actually asked the NRC to publish timelines for different application reviews. So that can be referenced on the NRC website, and you can see what those timelines are for different types of applications. And that would be, I think, the conservative timeline expected for any application type. So anyone can reference that. But what's even more exciting, I think, than that, and those timelines are actually much shorter than I think most people would expect, like, let's say, compared to timelines expected for an FDA process or maybe an FAA process, but they do involve a lot of pre-application work. I'll say since then, and where I was going with saying it was exciting, Congress has since passed, and most recently this year, an act called the ADVANCE Act. And again, another acronym there, but ADVANCE actually sets in motion additional impetus for the NRC, which is the Nuclear Regulatory Commission, to be even more aggressive on its timelines and more efficient in its licensing process. So some of the specific categories that bill called out for being more efficient is around small reactors, like the ones that Oklo is working towards. Of course, historically, we see across the country these large water-cooled reactors that might be a gigawatt in size. Companies like ours are looking at much smaller plants, and it stands to reason that smaller plants with advanced safety features should have more efficient licensing. And so I think Congress wanted to see the NRC feel even more impetus to look at their licensing process. Specifically, as I mentioned, they did call out small reactors. They also call out subsequent applications for the same type of reactor, and especially on sites where there's already nuclear plants. So it's not like a greenfield site. And that one actually shortens the potential lifespan, we believe, to 6 to 18 months as part of that bill, as well as corollary industry and regulatory projects are currently proposing. But specifically to Oklo, and it's referenceable as well, as that the NRC previously budgeted 24 months for a custom COLA review for us. And given the amount of time we've spent in other discussions with them since then, we could see it even being shorter. So between the three of those, publicly referenceable and kind of general timeline depictions for the NRC, that's where we come up with our timelines for review, which we've stated as 24 to 36 months. But I'd say that maybe the more exciting thing ultimately is how much faster we believe after the first of a kind we can get to much shorter timelines, partially because of what I mentioned with the ADVANCE Act, and partially just because of statutorily, the NRC only reviews generally new content in what's called a subsequent application. So subsequent applications for the same type of design, if you only need to review new material and that new material is only expected to be limited to new site material and it's the same design, we're expecting that to be much, much faster. So you can see from our recent earnings call and even our investor day from earlier this year, how we see those timelines lining up. But these are the inputs that we utilize to determine those timelines. And it looks like the next question is actually also to me. I'll answer it much more quickly. The next question is, what is the projected size of each plant? How many homes or commercial sites will be serviced for each plant? And again, you can reference our recent earnings call materials, as well as our Investor Day materials from earlier this year. We are working on plants of size 15 megawatts electric and then 50 megawatts electric. And we're also looking at larger sizes as well, which we talked about in those materials. Generally, as a rule of thumb, you might say about 1,000 homes to each megawatt. So you could think of a 15 to 50 megawatt servicing 15,000 to 50,000 homes. That is a very rough order of magnitude that you can think about. But generally, what we see our customer base looking like, and you may have seen this also in our materials, is that generally these are well sized for different industrial applications and particularly data centers. So it might be more like per data center kind of deployment that might match up to about that size. And so it's less so, do we think about it powering X number of homes, and more so, how does it fit in with different industrial sites and the customers that we see coming forward? Looks like the next question we have is going to Craig, so I'll pass it back off to you.
Thanks, Carolyn. So the next question is, can you address the backlog of orders? So I'd actually say it's a little bit building on what Carolyn was just saying. So one of the things we say internally is our goal is to build reactors customers want. So we're trying to actually deliver a product and an offer that matches the needs of the customers. One way we do that is by having both a 15 and a 50 megawatt powerhouse offering. And as Carolyn mentioned just a moment ago, we're also looking at 100 megawatts as well. So plant size is one thing. A second thing is we're actually trying to understand what is our customers' planned needs and how do we deploy powerhouses in a sequence. So just a couple of weeks ago, Jake and I were having a conversation with a new data center customer that's looking to build a greenfield data center site, so a brand new site. We were trying to understand exactly how they were planning on building out the data center campus so we could think about how to deploy most likely 50 megawatt powerhouses to meet their ramp up. And then finally, our entire regulatory approach, our entire design approach is based on repeatability and using existing supply chains. So our design and the technology that Jake talked about earlier, it's really trying to maximize the use of existing supply chains so we can ramp up deployment at scale. A great example of that is our recent announcement of forming a preferred supplier arrangement with Siemens Energy, where they're actually going to provide us our steam turbine generators, is one of those ways that we can deploy at scale. And that very first permit, when we receive it, is actually going to be a reference permit. So every time we're filing for a subsequent permit or permits, we'll reference against that permit, and we'll only be having to permit for what's changed or what's different, which is also really about trying to allow us to rapidly deploy assets at scale that's going to meet the power needs of our customers, now and into the future. I believe the next question is back to Caroline.
Thanks, Craig. Next question I have is, does management see an opportunity to power with large utilities? I'd say absolutely, but I would say there's a big cultural difference and general business model difference between us and at Oklo and large utilities and their traditional business model, and also what direction utilities are generally moving with their business model. So our biggest customers tend to be industrial, like I was mentioning, data centers, campuses, etc. And while sometimes those deals do involve work with utilities, that is not the main thrust of our business model. And so while we do see an opportunity, there's so much opportunity even besides that. I'll pass it off. The next question goes to Jake.
Thanks, Caroline. So the next question here is, have you considered any merging options with others currently operating in the mobile reactor industry? So at Oklo, we're quite focused on what we're doing at the 15 and 50 and looking at the sort of 100, maybe 200 range, but really right now the 15 and 100 megawatt plants and the opportunities they serve, which are tremendous in terms of providing power to industrial facilities, to data centers, to defense facilities, to utilities like Caroline was talking about, all sorts of energy off-takers and users. We don't really look at or spend much time looking at mobility or mobile reactors. They typically are going to be sized much smaller, servicing a very niche side of energy applications and come at really high cost. So pretty departed from what our core focus and vision is. So yeah, we're not really paying too much attention or spending too much work looking at opportunities there, given some of the implications and the unique sort of niche aspects of that side of things. And really focus on what we see as sort of the major drivers for our business at those size ranges, as well as some of the things that happen on the recycling side. That said, we do constantly look at and have broad awareness of different opportunities and technical implications of things. And ways in which we might be able to grow the business through constructive relationships and partnerships and the such. And what that looks like depends obviously on several different factors, but largely, what we focus on is really what's core to growing kind of the main parts of our business as we see it around providing power with proven demonstrated technical solutions with significant economic potential, as well as the benefits on the recycling and sort of isotope implications of recycling as well. All right, I think the next question here is for me. What progress has been made on considerations for hyperbreeding? And could this be used as a secondary income stream to process, enter, and use nuclear fuel from other facilities? It's an interesting question. Every once in a while, we get questions around breeding. And this is one of those kind of very exciting, cool things at a technological level that fast reactors like we're working on can do, which is actually produce more fissile isotopes than what you started the reactor up with. In other words, you put in fuel, and then after you run it for a little while and take fuel out, you actually end with more fissile material than you put in the core to start with. Sounds kind of crazy, and it kind of is, but it's a really cool feature. And it's because if you think about what uranium is naturally out of the ground, it's 0.7% uranium-235, the rest is uranium-238. Or if you use thorium, it's all thorium-232, generally speaking. Well, that means thorium-232 as well as uranium-238, which are the vast majority, if not the only naturally occurring isotope of those elements, are basically what are called fertile, which means they're not very directly fissionable. So they need to be exposed to neutrons. They need to absorb neutrons to turn into something usable. In the case of uranium-238, it's often turning into various isotopes of plutonium, or in the case of thorium, it's turning into isotopes of uranium. And in those cases, you can actually produce fuel from those things. It's a very neat feature set. However, it's one of the things that, as like from a design perspective, earlier in the sodium fast reactor technology development era, pursuing really aggressive breeding actually generally introduces significant costs into the system that aren't necessary if you're not breeding. And when we're focused really on delivering economic power, we don't actually need to breed aggressively. And that allows us to be focused on cost reduction and system simplification and avoid some of the challenges that come with that. However, the benefits of fast reactors that afford you those things also allow you to generally get much more fuel or energy out of your fuel that you load in, especially when you consider what you can do on the recycling side. So all in, there's a lot of fissile material that we have that's underutilized, as well as fertile material that goes into the reactor anyway, some of which does turn into fissile material. After all reactors generally put fertile material in, and it's going to turn into fissile material to some degree. Well, in a fast reactor, you can do that and take advantage of recovering that rather than throwing it away. To be specific, today's reactors, depending on the design and the plant, various things, they're often producing maybe 50 or more % of their power at the end of the fuel cycle from actually fissioning the plutonium that's built up in the reactor from the uranium absorbing neutrons, even though it was loaded with fresh uranium. But that's at the end of when they shut that reactor down at the end of the fuel life, they've only used a tiny bit of the energy that's available from those transuranics, and then they are generally going to dispose of that material. Well, that's where recycling gets really exciting, because you can take those components, those isotopes, those fuel elements out and use them. And in a fast reactor, you just can do that quite efficiently because of the tolerance fast neutrons have. Well, let me rephrase that: the actual capabilities that fast neutrons have in terms of fissioning across all sorts of isotopes of the various transuranics that are out there. So that gives us a lot of flexibility with the fuel you can use. So instead of getting into aggressive breeding, we just make the most of what fast neutrons can do by consuming actually the transuranics and also recovering the unused transuranics that we don't use in a go through the reactor. So the next question I see is for Caroline.
Hey, Jake. The next question I have is, what are the benefits to construction and startup of a small plant? And I'm going to add to that and say small and simple and safe plant, because I think those are all elements that the question is wants to get at, but maybe didn't ask. And the reason why I add that is, well, I'll walk through each. So benefits of a small plant are maybe kind of obvious, but maybe less obvious unless you've seen a large plant. These plants across the country that are gigawatt in size They're incredible feats of human engineering and construction. You might have thousands of people on site at any given time during construction. The length of construction is long, and that just adds to not only opportunities for error, as anyone could imagine, but finance costs. Finance costs can be the single biggest cost for construction of a large nuclear power plant, as studies have shown. It can be 30% or more of the total cost of a power plant, these traditional large plants. But if you think about thousands of people on a nuclear plant site working on things that, pouring concrete, et cetera, that might be considered nuclear grade concrete. One of them drops their flashlight in the concrete. You have to reevaluate the concrete. You have to go back through regulatory approval of that concrete. So you can imagine huge plants with large numbers of people and high requirements for the safety of that plant, because it doesn't have inherent safety characteristics. Just all compound over time. The logistics for small plants and small components of small plants are just totally different. For one, we can do a lot of commercially supplied components. Just recently, we made an announcement about our preferred supplier agreement with Siemens Energy, and we're really excited about that. That is really the part, the whole skidded thing that you can see in the image of the press release and our prior press release with Siemens around our MOU. Literally people standing next to it that can fit on a truck or train and be relatively easily transported. That same set of components that basically takes the heat and turns it into electricity in a large nuclear power plant could be many components, some of which have to be floated down on barges or specially constructed overseas and so forth. So we're really excited about the opportunities that small, simple, and safe plants present for simplification from everything across the board. For us, construction altogether is fairly limited as opposed to assembly and procurement of commercially available components. So you don't have as many people on site. You don't require that, and the level of difficulty of just the human factors and the logistical scheduling of all of those construction related elements is just totally different. And I'll get a little nerdy and maybe nuanced here, but when you have a lot of components that are called safety grade, that means those are you could say belts and suspenders required to keep the plant safe. If your plant has inherent safety characteristics, you don't need quite so many belts and suspenders. So less components are needed to keep it safe. And that's where our technology comes in. It's been proven over decades and so forth. And having those inherent safety characteristics, then you don't have to have all these components that have to be specially made, all these bespoke processes and documentation and approval sets, et cetera. One, that reduces cost, but also reduces complexity, and also means more things are available commercially than if you have to have them be specially made with certain kind of characteristics to meet that standard. So it's important to us to have something that's not just small, but simple and commercially available in that sense. So we're not using crazy materials, etc. And then also safe inherently, so that we don't need a lot of additional systems to keep it safe. So it stays very simple in that way. So hopefully that helped illuminate to the question of what are the benefits to construction and startup of a small plant. I have the next question as well. What are the possible bottlenecks in fuel supplies? I might phone a friend and see if either Craig or Jake want to add into this. But fuel supplies you can think of in 3 different components. One is the mining of uranium. Generally speaking, there are other ways of doing it, but mining, and then enrichment, and then fabrication of the fuel itself. Generally, the bottleneck in our world today is around enrichment, and part of that is because of bans on Russian enrichment and etc. So there are tremendous domestic supplies, and one of the silver linings we see to that is because of the constriction and supply from Russian sources, it's just a further motivation to the US domestic market to ramp up enrichment. And we've seen that a lot recently, a lot of efforts towards that, funding from the US government going towards that, and just overall money and financing going towards reinvigorating that domestic supply, which we did have previously and now are reinvigorating for domestic enrichment. That's also where Oklo has already been seen for many years past that, to say, okay, how do we, get the enriched supplies we need for now, but how do we set up a large commercial supply chain for recycled material that doesn't require enrichment in the future? So we have that domestic supply chain that kind of acts as a hedge to our concerns around bottlenecks in fuel enrichment. So those are a couple of the key areas. Obviously, there's the general scale-up concerns that we have around building a fuel fabrication facility, building up that recycling facility, et cetera. But we see the paths for those. So I think generally at Oklo, we've been thinking very carefully around our fuel supply, both for the early plants, which we're working with INL to do recycling of the fuel for that, our kind of mid-range plants where we're working with different partners that we've announced, like Centrus, around procuring enriched material, and then our long-term plans, which are around not just using recycling like it's done on a smaller scale for our first few plants, but a huge and scaled up process for our expansion and scale up of all of the powerhouses we see in the future.
I just chime in and say, on top of what Caroline said, well, we see the supply chain gearing up to basically address now replacing that capacity, which we see constructive across the board for just accelerating deployment of new enrichment capacity. It also touches into sort of the other parts that lead in, the sort of the nuances that lead into enrichment, including the conversion side and enrichable materials such as hexafluoride gas, uranium hexafluoride, which would be a solid or a gas depending on temperature, pressure, and then also the deconversion part, which I think in today's supply chain is probably it looks one way, but with these advanced reactors and how we envision it, there's some opportunities to sort of change how that looks, which I think is kind of a cool feature. So part of the partnership we have with Centrus is obviously off-taking fuel or enriched fuel products that we can then fabricate, but there's also some other parts about how we can look at maybe collaborating on other aspects around, accelerating the availability of infrastructure to support those other parts to ultimately be able to fabricate fuel and load them into our reactors. Cool.
I think the next question goes to you, Jake. Yeah.
Thank you. Thanks, Caroline. I think so the question that we also often get is an interesting one about basically what are, if any, updates on the Air Force Base project in Alaska. Is it still being considered, and are we still in the running? So we've been awarded that project 2 times, and then it's gone through, for those who are familiar with, the unfortunately very normal basically procurement cycles for defense projects, meaning protests for those who didn't receive it, and kind of the cycles of those activities. So we were awarded it about a year ago, and then it was pulled back as they re-reviewed based on some potential protests. Then it was re-awarded to us in February, and then it was pulled back after there was a protest filed. So we're supporting and engaged in this, but expect this to continue to work itself through the procurement process, which does just take some time. But we do very much consider ourselves still in the running, especially given the fact that we've been awarded this twice. So the last question, actually one question I'm just going to kind of add in here that's I think interesting one that Caroline hit on well, but it's one of the reasons we were particularly excited to bring Craig on the team a year ago. Well, there are many reasons, but one of them is building on his experience set coming from very large energy infrastructure projects and his experience around those. And I think there's some things Craig really latched onto and has been able to help us think through, plan around, communicate, and work through accordingly around sort of his experiences around those and sort of the contrast of really big, dare I say, mega projects versus small projects. So, Craig, if you don't mind, I'll put you on the spot before we break into the last question here and close out.
Sure, that's fine, Jake. So I spent 30 years in the oil and gas sector, predominantly with BP, and one of the oil and gas terms you will hear that Jake just referenced is a mega project. Typically, a mega project is a project that starts out being at a cost factor of several $billion, and it normally starts out with a very long duration of 5+ years. Typically, mega projects, in terms of their cost, only tend to go in one direction, which is more. And in terms of their duration, they tend to go in one direction, which is longer. So one of the things that really impressed me when I got to know Oklo and Jake and Carolyn and the business that they've created is the entire approach to our assets and our size is to avoid mega projects. And the other thing that's kind of cool is because we intend to keep building the same kind of asset over and over again, through that repetition, we should bring down the time to delivery, the cost to delivery, the utilization of existing supply chains means there's probably some scale economy benefits that we can also leverage, and avoid mega projects. Because like I said, a project that starts out large and starts out long and tends to go more expensive and a longer duration is normally something that you want to avoid. So I think it's just great that through our size and our technology, we're actually building a business that looks to avoid that.
Thank you, Craig. It's one of the big things about, it's a funny thing to say, but one of the big things about being small. It's cool. With that, I guess we've got the round robin questions, which I kind of love, which is basically, what is the biggest thing each of you are excited about with Oklo? I'm going to go ahead and I'll propose I go last, if that's okay. How about we start, Craig, with you, and then Caroline, and then me, and then we'll go ahead and wrap from there.
Sure, Jake. So, what really excited me when I first started talking to Jake and Carolyn, and excites me every day, is I'm somewhat joking, but I'm also very serious. I worked in the energy sector for 30 years. And it only took me 30 years to finally find a company that had a product and an offer that customers want to buy. And so when I'm privileged to be in customer conversations with Jake and Carolyn and Brian Gitt and others in our company, what really excites me is how excited our customers are about our clean, affordable, reliable offer, and wanting our business to help enable their business. So that's a really exciting place to be. The second one's a little more personal, just the excitement in with my family and with my friends when I first told them about joining Oklo a little over a year ago, and all the exciting things that we've accomplished, prior to my joining, but the things that we've done since then. It's just exciting every day to get up and go to work and say I work for Oklo.
That's awesome. Yeah, with that prompting, I feel like maybe I'll start with the personal side, like what gets me out of bed, and then what I'm most excited about for the future. I think, working on this with Jake and since the founding, it gets me out of bed because I feel like there's otherwise it'd be too scary to face the world, I think, in some ways, without feeling like tangibly each day I'm hopefully contributing to something that I really truly believe is the only really scalable solution to huge problems that we have today, whether it's ecosystem loss or other kind of really key issues that bother me if I think about them, but at least I know that we're working towards solutions there. So that's what gets me out of bed each day. What am I most excited about? I think, honestly, turning on that first plant, there's gonna be nothing like that. So I think just working towards that, but also knowing like the plans for past that. We've always said, if we just did one plant, it would obviously be a failure in terms of our goals. And so we've got all the plans in place for everything beyond that, but I think there's going to be nothing like that feeling of being there that day.
I love hearing all these, and honestly, those are all those motivate me, and I think the team is one of the biggest things that motivates me about what we've been able to build together and how mission aligned and how passionate everyone is. And I think that gets to then the maybe the personal side and what goes to sort of when I fell in love with this technology as a whole. At the end of the day, we're talking about a system, a technology set, right? From fast reactors with recycling, we know works. We've done it before as a country. That has the fundamental potential to be able to power the entire planet's energy needs for billions of years with known and accessible reserves of heavy metals. I mean, that's insane because you're talking literally about a proven terminal energy and climate solution. There's just nothing else like that. So that mission is pretty pretty easy to get really excited about, and I think the thing that keeps us going. Obviously, it's a long time frame. I have we sometimes joke with Craig about the multi-billion year discounted cash flow analyses. Uh, but at the end of the day, we're trying to build something that literally reaches those levels, and that's a really easy thing to be really excited about, and including in ways that honestly are going to transcend our lifetimes, which is cool, right? It's something that obviously is probably one of the most important things people can work on with something that we know can make that kind of impact. So, an exciting place to be for sure. Well, I'll just go ahead and say thank you, Craig and Caroline, and I'll pass this back to Bonita. And thank you, Bonita, for getting all this to happen and organizing this.
Yeah, of course. Well, that was a great last question, and it wraps our first AMA. Thank you, everyone, for joining and for your questions. It truly means a lot to us to connect with you all directly and to share more about Oklo's journey and future plans. So, before we wrap, we do have a little something special for those of you who have stayed with us until the end. As a token of our appreciation, we are offering a giveaway. The first five people who email us at media@oklo.com will receive some Oklo swag. So do send your emails in, and thank you again for your time and support. We look forward to hosting our next AMA and continuing this conversation. See you next time.